Here is the second pattern from the Gang of Four. This one is called Builder pattern, and it is a pattern you use when creating new objects. Here's a quick summary of what we're trying to accomplish with this pattern. The Builder pattern is a good choice when you are trying to accomplish the following. You want to separate the construction of a complex object from its representation, so that you can use the same construction process for different types of objects. Or you want to parse a complex representation, let's say an XML file, and create one of several target objects out of it. Let's go through the points one by one. So, in the first case, you have some kind of complex object. In the terminology of this pattern, we call the object a product. Usually, the product will be an aggregate object, meaning it is an object composed of two or more child objects. We call these child objects parts. There are a lot of possible permutations of parts. So instead of adding lots of complicated construction code in the product itself, you instead move all that code into a separate builder class. Now, the builder is responsible for constructing the product by repeatedly creating and adding parts until the product is complete. The idea is that different types of builders can create different products by adding different combinations of parts. So in this setup, the product represents pure data, and the builder represents the construction process, and the two are kept strictly separate. You see this same type of separation in the second case, where we are parsing a complex representation and reading the data into a product. For example, there might be different types of financial transactions stored in XML and text files. A single abstract transaction instance can be initialized from either an XML builder or a text builder. Both builders read in the external files, extract the data, and use it to construct a new transaction instance. The builder pattern offers a number of benefits over straight-up construction of objects using the new keyword. First, the builder pattern is ideal if the construction process occurs in a number of discrete steps instead of all in one go. The builder creates a new product part each time it's called, and it maintains all intermediate state. When the product is finished, the client can retrieve the finished product. Second, this pattern establishes a strict separation between data representation and the construction process. All the complex code for constructing the product is hidden away in the builder class, and the code of the product classes stays clean. Third, the pattern is convenient when a single product can be represented by several representations. For example, the product might be encoded in an XML file, a binary file, or a text file. In the builder pattern, we would use 3 different builders to construct a single unifying product instance from these 3 sources. Finally, the builder pattern offers fine-grained control over the construction process. Unlike creational patterns that construct products in one go, the builder pattern constructs the products step by step. This offers more flexibility. Here is the UML diagram of the builder pattern. The pattern is fairly simple, with only a few classes. The builder class is an abstract base class that specifies an interface for creating the parts of a product. Usually, this interface will be in the form of multiple abstract buildPartXXX methods. The director will call these methods in the correct order to assemble a product. The concrete builder is a subclass derived from builder that actually constructs and assembles the parts of a product by implementing the builder interface. The class uses a protected field to keep track of the product it creates, and it provides an interface for retrieving the product. This will usually be a method called getResults or something. The director is responsible for constructing a product using the builder interface. You initialize the director with a concrete builder. The director provides a construct method that will call each buildPartXXX method to assemble a complete product. And finally, we have the product class. This class represents the complex object under construction. The concrete builder builds the product's internal representation and defines the process by which it's assembled. What might surprise you is that you use the director to build a product by adding parts in the correct order, but once the product is finished, you retrieve it directly from the builder. This is another separation of construction logic. The builders only specify how to add specific parts to the product. The director only decides which part methods to call and in what order. Let me show you an example of the builder pattern. I am going to write software for a fast food restaurant. You might have noticed that places like McDonald's or Burger King work with standardized menus. There's always a burger, fries, drink and a dessert on the menu. And the kids menu doesn't have a dessert, but it includes an extra toy. So the products in this example are the actual menu, and the parts are the various food items that make up the menu. There are different types of menus in a fast food restaurant. There's always a burger menu, a salad menu, and a kids menu. So I am going to need 3 different menu builders to create these menus. Finally, there's a director class that's responsible for assembling the components of a menu: a burger or salad, fries, a dessert, and optionally a toy for kids. So I am going to implement the pattern with the following classes. Okay, let's take a look at the code. I'll start with the menu director. This is a very simple class with a construct method that accepts a single menu builder argument. The director then assembles a complete menu by adding all the possible components: a burger or salad, fries, a dessert, a drink, and a toy. Next is the menu builder. This is the abstract top-level builder class that constructs an entire menu. There are builder methods for adding a burger or salad, fries, dessert, and a toy. Finally, there's an abstract getResult method to retrieve the finished menu. Next are the concrete builders. You can see that I have builders for a burger menu, a salad menu, and a kids menu. Each builder implements the build methods in a different way to create that specific menu. And next is the menu class. The menu is an aggregate object that uses a dictionary to store the parts that make up the menu. There's also a toString method to return the entire menu as a string. And finally, let's take a look at the main program method. The code here initializes a burger menu builder and then uses a menu director to assemble the complete menu. Then it retrieves the finished menu from the builder and displays it on the console. The next code fragment does the exact same thing, but this time for a kids menu. Okay, let me run the program to prove to you that everything is working. I am compiling the code now. And now I'm running the program. And there you have it. One burger menu and one kids menu. Everything works. Okay, here is a quick checklist you can use to implement the abstract factory pattern. First, make sure you have lots of aggregate products that differ only in their permutation of internal parts. And your construction code involves a number of sequential steps. Then create a concrete builder class for each product type and move each construction step into a separate build method. Then design a standard protocol for all build steps and capture the steps of this protocol in the abstract builder class. Then define a director that calls the builder methods in the correct order. And finally, make sure that the client does not use new anywhere and only uses the builder to create new instances. Okay, here are some final comments. What I've shown you so far is a builder pattern that uses simple methods to create parts. But you can also use a prototype or factory pattern to create the parts. Pick the creation pattern that best suits your needs. The builder pattern is especially useful to create composite objects. The composite pattern is a structural pattern that we are going to discuss in an upcoming lecture. And finally, you usually start out using factory methods to create objects. But then, as your code gets more and more complex, you might want to refactor your code to a prototype or builder pattern. This is perfectly okay. Feel free to swap one pattern for another as your code evolves. Alright, here's the summary of what we've learned. The builder pattern provides an interface for constructing a family of complex objects in multiple steps, so that you can use the same construction process for different types of objects. Use this pattern if your objects can be grouped into sets that differ only by the permutation of their internal parts, and if the construction process consists of a number of discrete steps. The director class ensures that the order of build steps is always the same for every type of object. The calling code never instantiates objects directly, and it does not need to know the exact details of the build process. You can combine a builder pattern with a prototype or factory pattern. It's perfectly fine to migrate from a factory pattern to a builder pattern as your code evolves.